So we are talking about what is probability. In order to understand what probability is, we first need to know what the definition is. Probability is a numerical measure between 0 and 1 that describes the likelihood that an event will occur. Later on in this term, we're going to look at multiple events happening at the same time. But for this first unit, we're only going to be looking at a single event. Starting off, we have this P parentheses A, which is read as P of A. What that means is the probability of event A. So keep that in mind. Now, you said in the definition it's a measurement between 0 and 1, but it could equal 0 or it could equal 1. If the probability of A equals 1, what that means is the event A is certain to occur. It is guaranteed to happen because 1 as a percentage is 100%. If P of A equals 0, what that means is that the event A is certain to not occur. It is guaranteed to not happen. It is a 0% chance. Now, there are 3 different types of probability assignments that we could have. First is intuition. Probability based off of intuition incorporates past experiences, judgment, or opinions to estimate the likelihood of an event. We're guessing. Relative frequency uses this formula, F divided by N, where F is the frequency and N is the number of observations. In other words, we are running trials. We are rolling multiple dice. We are spinning a spinner multiple times. We're pulling a card from a deck multiple times. And then the one that we're going to use a lot of is this equally likely outcomes. And it's a formula that I always refer to of P of A, or the probability of event A, equals success divided by total, or success out of total. So let's look at example 1. We're going to consider each of the following events and determine if the probability is how the probability is assigned. So, first one, a sports announcer claims that Sheila has a 90% chance of breaking the world record in the 100-yard dash. Since there are no trials being done, and they're claiming, and it's not really based off of anything, this one is going to be based off of intuition. The second one, Henry figures that if he guesses on a true-false question, the probability of getting it right is 0.5. For this one, he isn't running trials, but he isn't basing it off of past experiences. He is basing it on, well, there's one right answer out of 2 possible options, so this is an equally likely. And then the last one, the Right to Health lobby claims that the probability of getting a wrong medical lab report is 0.4, based on a random sample of 200 lab reports, of which 80 were wrong. Now, this whole entire bit, where it says based on a random sample of 200 lab reports, that right there tells me that they are running trials. Now, the only one that is dealing with running trials is our relative frequency. We also have this idea of law of large numbers. Now, law of large numbers is a rather important thing. Law of large numbers helps explain why the relative frequency answer or probability might not equal the theoretical or the equally likely outcome probability. What law of large numbers says is the more trials you run, the closer the relative frequency gets to the theoretical or actual probability. So the more trials we do, the closer that probability gets to be our actual theoretical probability. Because the theoretical probability is, in an ideal world, this is what would happen. We would roll a die, and every 6 times we roll it, we would get a number 1, 2, 3, 4, 5, and 6. That would be in an ideal world. Now, in reality, that's not the case. So, a statistical experiment can be thought of as any random activity that has definite outcomes. Definite meaning there is no unlimited possibilities. We pull a card from the deck of cards, and it's either a red card or a black card. That is a definite number. An event is a collection of one or more outcomes of a statistical experiment. Meaning the event pulling a king from a deck of cards. A simple event is one particular outcome of a statistical experiment. And then the set of all simple events is called a sample space. We will be making a lot of sample spaces in this class. For example, in example number 2, for a carnival game, a turn consists of rolling a 6-sided die twice. If the product of the two numbers is odd, you win. If the product of the two numbers is even, you lose. In addition, if the product of the two numbers is 3, you win a grand prize. Now remember, product means you multiply the numbers together. In part A, it wants us to list all possible outcomes for the sample space. So, if the first card, or first die roll, is a 1, the second one could also be a 1. Roll 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, and 1 and a 6. And that's all the options if our first die was a 1. Well, what if the second die was not a 1? What if it was a 2? Well, the second die could be a 1. You have a 2, then a 2, 2, then a 3, 2, then a 4, 2, then a 5, 2, then a 6. What if the first die was a 3? Well, we could have a 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6. I hope by now you guys are starting to see a pattern with these. So go ahead and pause the video and fill out the rest of these. Okay. So all in total, we have 36 possibilities. because there were 36 different combinations that we had. So for B, it says describe the event winning the game as a list of outcomes from the sample space. So in other words, we want to know what number combinations can we have to win. Now, once again, to win, the product has to be odd. In other words, neither of the numbers can be an even number. So going through our list, the only possibilities then are rolling a 1 and then a 1, rolling a 1 and then a 3, a 1 and a 5. So none of the numbers can be even, so I can't do any of the 2 column. I do a 3 and a 1, 3 and a 3, or a 3 and a 5. Can't do in the 4 column. I do a 5 and a 1, a 5 and a 3, 5 and a 5, and I can't do any of the 6 column. The last part of this says, what is a probability? So if we go look at that theoretical probability, it was success out of total. Well, the number of successes for winning the game, well, there are 9 numbers total. There'd be 9 out of the grand total of options, which was 36. Now notice, I didn't write this number as a decimal. To save everyone time and energy and a headache, we are just going to leave our answers as a fraction. We do not have to simplify. Looking at C, describe the event losing the game as a list of outcomes. So in other words, the events that we did not list in B, we are listing in part C. So that'd be a 1 and a 2, 1 and a 4, 1 and a 6. That'd be all of the numbers from the 2 column. That'd be 3, 2, 3, 4, 6. All of the numbers from the 4 column. BR5, 2, a 5, then a 4, 5, then a 6, and then all of the numbers from our 6 column. And then this too wants us to have the probability answer. Well, counting all of our numbers of options of the success, you would get 27 total of them out of this 36. Once again, I did not simplify my fraction. I did not put it in as a decimal. Go ahead and try part D, grand prize. So to get the grand prize, we have to have a product of 3. Well, the only way to get a 3 would be a 1 times a 3 or a 3 times a 1. So those were our only 2 options, meaning our probability would be 2 out of 36. Let's look at example 3. Table to the right shows the number of times a letter is selected from a spinner spun 185 times. So that tells me that we are going to need to do that relative frequency. What is the relative frequency of getting a B? So relative frequency was our F divided by N, or our frequency divided by the total number of observations. So how many times did we spin a B? That'd be 59. Out of, well, how many times did we spin the spinner? Well, that was 185. Last bit. First, did you know that the sum of the probabilities of all simple events in a sample space, it must equal 1? It is impossible for a probability to be more than 100%. It cannot be more than 1, it cannot be less than 1. Which gets us into this idea of a complement. Now, this is a different complement than in an English class. We're not praising someone about their shoes. What a complement in probability is the opposite of an event. A to the C, notice on how it's capital A. A to the C is the complement of event A. If you look at this Venn diagram, I know it looks like a weird Venn diagram, but A, the circle with the blue, is all of the events that we're looking at. Meaning the complement or the opposite would be everything not in that circle. And that word not is what we're going to be adding to describe a complement. There are two things about it. First, the probability of event A plus the probability of complement of event A has to equal 1. Meaning, once again, if you look at that circle, everything in the circle plus everything outside of the circle has to equal every possible option. Our second one, using some algebra, would be the probability of the complement is equal to 1 minus the probability of event A. So let's look at an example. Example 4. Example 4 says, a bag of marbles contains, well, marbles of various colors. The table below shows the probability of pulling each color marble. A, what is the probability of pulling a yellow marble? Well, like we said before, all probabilities have to add up to 1. So I can do, or 100%, I can do 100 minus each of these probabilities. So minus 15, minus 28, minus 7, minus 30, minus 12. To get our missing probability. By doing all of that, we get 8%. Part B says, describe the complement of pulling a purple marble. Now, once again, complement means opposite. Now, be careful. Before we had people say, well, pulling a blue. Well, blue might not just be the only thing that's the opposite of purple. We could say pull a blue, red, green, yellow, or orange, or, to make life easier, not pulling a purple. Keyword, not. So then, what is the probability of the event in part B? So that complement, and we talked about the complement was the same thing as 1 or 100% minus the probability of that event. So the probability of pulling a purple. It would be 70%.